Welcome to our fifth STEAM project, based on the BBC Microbit, the GeekPy Microcar and Microsoft MakeCode, in which we will make our robot follow a black line. This course is at the introductory level. We actually assume that you don't have any prior knowledge of programming, sensors, or actuators. We call this level the Scout level. My name is Peter. I am the founder of Educommando and a certified STEAM instructor and course designer. In this project, we will learn how to work with an active infrared sensor. And here I am showing a larger model. What will we do? Well, we will capture the digital readings of the infrared sensors, so either a 0 or a 1. We will continuously compare those readings with each other. And by comparing the digital readings from the sensors, we convert these into digital write commands for the motor pins. Quite some experimenting in front of us, so let's get started. The active infrared sensor contains a transmitter of invisible infrared light and a receiver that measures how much of that is reflected back. The difference in reflection between the black line and the surrounding surface allows the robot car to kind of see and follow the line. White will reflect a lot of light, so that will return a 1. Black absorbs the light, so that will be a 0. The robot car has two sensors on the bottom, one on the left side and one on the right side. They are connected to pins 1 and 2. So remember those pin numbers once we start the block programming. Of course, to make the microcar move, we need to activate the motors. If you are unsure about how to control the DC motors, have another look at the previous project where we programmed the robot car to follow the brightest light source. Now it's time to go to the MakeCode block programming. Here we are in the Microsoft MakeCode environment. We create a new project, we give it a meaningful name, for instance, robot car line tracker. I hit the create button and we are in the programming environment. For this project, we don't need to install any extensions. As always, when working with these robot cars, the first thing to do is to disable the BBC Microbit's onboard LEDs, because these will create pin conflicts with the robot car. And I do that by selecting LED, More, and pick LED Enable False. I drop it in the On Start block. And as you can see, the code snaps into the empty space. The second step is to program the motors to go either forward, forward left, forward right, and a full stop. The good news is we have already done this in the previous project, which makes our lives really easy because we still remember what the programming is. The only difference is that we will make the turns somewhat sharper because we want as much control over the movement as possible. Specifically when the robot car will encounter some sharp bends. So what we want to do is that when one wheel goes forward, that the other wheel will be set to go backwards, and that will make the pivot sharper. So how do we do that? Well, we have to create functions, as you still remember. Make a function, we call the function forward, and we populate the function with some digital writes from the pins. And remember that we have 4 pins for the motors. So I'm going to copy paste this function a couple of times. We know that is pin 13, pin 14, pin 15, and pin 16. To make both motors to go forward, we have to activate pins 14 and pins 16. So those will be put on 1. So that's the first one. The second one, I'm going to do the left. So I can rename it to left. And to go to left, I need to activate pin number 13, disable pin 14, and activate pin number 16. So that will make the car go to the left. Once again, I'm going to copy paste, and this one I'm going to rename to right. And to turn right, it's the opposite pins. So pin number 13 needs to be set to 0. Sorry, 0. Pin 14 is set to 1. Pin 15 is set to 1. And pin 16 is set to 0. We also want to include a full stop, just in case the robot, for whatever reason, like someone pushes it, of course by accident, and it's going to leave the track. We don't want that. At that moment, we really want the car to stop. And a full stop is, of course, achieved by setting all the pins to 0. Stop, and pin 14 set to 0, and pin 15 is set to 0. In the next steps, we need to compare the digital readings from pins 1 and 2. In the logic block, we were going to select an if statement, and we're going to put it in the forever block. And we are going to replace this true with another option under logic. And that's a Boolean, because we want to compare 2 values. Now I need to to replace these 2 with with the digital readings, and compare those with these elements. So we will go back to our logic, and I'm going this time to compare this one, and I'm going to use the same one to put it here. Okay, that looks good. Now I need a digital read from a pin, so go back to the pins, and I'm going to have my digital read. I'm going to replace the first value, and I'm not using pin 0 here, but we are using pins 1, and I'm going to write, so if digital read pin of pin 1 is equal to 1, and the digital read pin which I still need to replace here. The digital read pin of pin number 2 is also 1. What happens then? Then I have to call my function forward. In that case, the car will move forward. And why is this? Because both pins, the digital read of pin 1 and pin 2 is 1 because it is on white. So you can see the logic for the other forever blocks, and the best way to do that is to create 4 forever blocks, each with a single if statement, and each of them linking to a combination of states that will link to a certain direction. So the first if statement shows the situation where both of the pins are reading from, or both of the sensors are reading from a white surface. The second one will be copied, so I just copy it. I'm going to make the screen a little bit smaller and clean it up so that it's easier to read and to follow. Okay, that's better. The next situation is that we set the pin 1 to 0 and the pin 2 to 1. What will happen there? Well, I need then to call the left. So this is going to turn my car to the left. So call left, and I'm going to put it here. Copy paste again. And moving it underneath. If pin 2 is on white and pin 1 is on black, so this one is then 0 and pin 2 is on white, so that's on, it's going to be a 1. Then the car has to move to the right. So I'm going to call the function call right. Okay, call right. And last but not least, we want the car to stop in case it gets off the track. And we do that by checking the condition that both sensors are on black. So both will return a digital signal of 0. So this one is also on 0, and so right will be replaced by call stop. I think we are ready to download the program, and once that is finished, let us see what the robot is doing in reality. So I'm connecting the robot. And I'm going to download. And once that download is finished, you can disconnect the microcar from the USB cable and place it on the racetrack. And here we are, we place the car over the black line and switch it on. And as you can see, the car is finding its way along the track. So it seems that everything is working. That's it for this project. Here are some ideas. Ask your students to create a longer track with multiple bends. You can do this with black tape on the floor as long as the floor isn't too dark. If the floor is dark, you may want to put a white tape and adapt the programming. You can also include some challenges, like a line interrupt or a crossing. Observe what is happening with the microcar and let your classroom discuss what they would do to solve this problem. Curious to hear how inventive they are. That's it for project number 5, in which we were able to make the microcar follow a predefined black track. In our next project, we will let our microcar run independently and use an ultrasonic sensor to ensure that it doesn't bump into obstacles. Bye bye for now.